Okay, question number 25. In the diagram below, CD is the median, or CD is the median. That means it is from the vertex joined to the base, and it bisect the base, or median, right? Points E and F lies on AC and BC respectively. If EF and CD intersect at G, and then CA to CE plus CB, CA to CE, and your CB to CF is equal to K time of CD to CG, where K is a rational number. Find the value of 12A. Actually, this question, they didn't mention the ratio. They didn't mention the ratio, right? That means it just say that CA to CE. That means CA here to CE, right? And then CB all the way to CF. Therefore, we can actually look at a special case. We look at a special case. That means what happens if your E and F are the midpoint? That means your CD is the median. This is a CD, this is the median, right? This is AB. And what happens if your E and F are midpoint of AC and CF respectively? Then in this case, can you see that your CA over CE will be just equal to 2, right? And then your CB over CF would be just equal to 2, right? Then in this case, can you see that your CD to CG is also equal to 2, therefore, if you look at the ratio, that means in this case, can you see that CA to CE plus CB to CF is equal to K times of CD to CG. Then you will get 2 plus 2 and equal to 2 times K times 2, K multiplied by 2. K multiplied by 2, therefore the answer to K is actually 2, basically. Alright, therefore you will suspect that the answer to this question is actually 2. Alright, it's actually 2. Because it's a special case. Therefore now we look at this general case. That means CA to CE. Can I put it as because CA is longer, right? Therefore, can I say that it is actually what? It is actually CE plus BF. CE plus EA, right? Plus AE, plus EA to your CE. Therefore, is 1 plus EA to CE, or EA to CE. Okay, before I do this, I think I need to draw an additional line. Can I draw a line in such a way that this line is actually parallel to AB, or is actually parallel to AB. All right. Then after that, I think I want to extend this line all the way, and then I extend this line all the way. All right. Then can I call this point here X? Can I call this point here X, and then I call this point Y? All right. Then in this case, what is okay, in this case, EA to what? EA to CE, to CE, this one is the same as what? It's the same as A, because can you see that these two triangles are similar? That means this triangle, okay, let me just highlight. This triangle is going to be similar to this triangle. I think you can verify yourself, because this angle and this angle are the same, right? And then because they are parallel line, therefore this angle and this angle are the same. Therefore these two triangles are actually similar. Therefore, I think now I can extend this concept to what? It is actually 1 plus AY is to CX, or is to CX here. All right, therefore this is CX. All right, then next I want to look at the next ratio, CB, or CB to CF. All right, then in this case, this is 1 plus BF, BF to CF, or BF to CF. Therefore, in this case, can you see that BF, it is actually this one, BF to CF, or BF to CF is the same as what? Can you see that now? Now, can you also see that? Look at this triangle here. Okay, can I highlight this triangle? This triangle is actually similar to this triangle, right? It's actually similar to this triangle. Therefore, it is actually equal to BY to CF. That means in this case, okay, therefore, can I say that it is similar to what? It is similar to BY, BF to CF, right? That means BF to CF, okay, is similar to BY to CX, to CX. All right, yeah. Okay, then finally, I want to look at CD to CG, or CD to CG. Okay, this is actually equal to what? This is actually 1 plus DG over CG, over CG, over CG. All right. Then this would be just equal to what? Therefore, I think I can draw another triangle. That means this triangle here, this triangle is again similar to this triangle. All right. Therefore, it is actually dy over cx, dy over cx. Therefore, this part here is plus dy over cx, or dy over cx. Therefore, I think let's look at the left hand side. The left hand side is actually CA over CE plus CB over CF, right? And then now this is actually 1 plus AY over CX plus 1 plus BY over CX. Therefore, what you get is 2 plus AY plus BY over CX. All right. And can you see that you look at this thing, AY is here. AY is here. And then your BY is here. Your BY is here. Right? And in this case, can you see that this total length is actually what? Can you see that this is A, right? Therefore, I think the total length here is actually AY plus A plus A, right? Plus A plus A. Then plus BY, sorry. Okay, what is AY? AY is just AY, right? AY. And then what is BY? BY is actually this thing, right? It's actually AY plus 2A, or AY plus 2A. All right. Therefore, AY plus BY is actually what? Is actually twice of AY plus is twice of AY. Is twice of AY plus 2A, right? This plus this, and then plus 2A. Therefore, it is actually twice of AY plus A. Therefore, in this case, what is AY plus A? It is actually y dy. Therefore, it is actually twice of dy. Therefore, this will be 2 plus twice of dy divided by cx. Divided by cx. Right? And what is dy? Okay, therefore now we can take out common factor. Twice of 1 plus dy over cx. But this one, can you see that 1 plus this? Isn't that this is actually equal to this? That means this is twice of cd over cg. Therefore, in this case, this number 2 is actually your k, which is actually same as the special case. Therefore, now they want us to find the value of 12k, which is 12 times 2, and the answer is just 24. That's it.